Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. And today I will be talking about projections, vectors and projections, and how practically in practice use this. Because I tell you the truth, unless they ask you directly how to add vectors using triangular law or how to use vectors using parallelogram law, we always will be solving it 99% of the time. We will be solving those vectors using projections. And the reason for this is very simple. Say we have the system of coordinates on our plane. And say we have this vector A. And we can tell that this vector A can be represented as a sum of two vectors. This vector plus this vector. So, vector A is the sum of A1 and A2. And we can say A equal A1 plus A2. That's triangular law, or if you want, you can put it here and it will be a parallelogram law. Doesn't really matter. But A1 plus A2 equal A, and it's very simple and straightforward. And the only trick that I did, that I said, okay, let's forget completely about A. Instead, we have A1 and A2. So you have choice. Either you have vector A that's represented by its length and the angle. Or you say, I don't want those two numbers. Instead, I want those two vectors instead of this. And this vector is parallel to x, and this vector is parallel to y. So, A1 they put it AX. Nobody write A1, they put AX because it's projection on this. And A2 they write it AY because it's projection on Y. And so, after we do this, we start acting in two different directions independently. For example, we have some vector F equal F1 plus F2 plus F3. We have three forces. And they want to add those three forces together. And we can draw one vector, one parallelogram law, one triangle, but it's much simpler to introduce axes and to deal with projection along x-axis and along y-axis. For example, I will start straight with examples. Let's say we have one vector and its length is 3 and this angle is 30. And I have another vector and I don't know, anywhere. Its length is 2 and this angle is 45 degrees. And they want to add us. So this is the first vector and this is the second vector. And they want us to add this. Of course, we can do through triangles, through anything, parallelograms. By we don't do this. This is x and this is y. And we say that a plus b equals c. And we say right away that ax plus bx equals cx. So we take projection of this vector on this, projection of this vector on this, and we obtain cx, projection of coordinate x. And we can say ay plus by equals cy. And basically that's it. So now we have to deal with this ax. This is 30 degrees and projection would be a cosine, and let's put it theta or alpha, and let's put this beta. And then later A cosine alpha would be this, plus B cosine beta. And the only thing, they both look this direction, so it's all positive. And it would be Cx. And we can do the same along this vertical axis. We'll say Ay, it would be A sine alpha. And here is a trick. B is pointing down, so it would be minus B sine beta. And this would be Cy. And basically we need to find Cx and Cy, and I can continue in characters, but this is like a real case, so simple that I can already obtain Cx and I can plug the number. A is 3 cosine 30 degrees, right? Plus B is 2 cosine 45 degrees, and Cy equals A is 3, and I multiply sine 30 degrees, and I put minus B, and B is 2, and this would be sine of 45. And of course you can use the calculator and stuff like that, but I'm lazy and I don't have a calculator, it's too expensive device for me. So I write Cx equals 3 cosine 30 degrees, it's what it is. You can revisit couple previous clips and you will see that this is square root out of 3 divided over 2, right? Plus 2 cosine 45 is pause and write square root of 2 out of divided over 2. Cy equals 3 sine of 30 is pause, revise, use a calculator if you're lazy, 1/2. Minus 2 sine 45, I will not pause, I will write that it is this. And that's it. Cx equal square root of 3. I say it's 1.7, roughly. So 3 1.7, it's very roughly would be, I will put here 2.2. Plus this 2 is gone, 1.4. It's very roughly would be 3.6. You may correct me, but I think I'm pretty close. Cy equals 3 over 2, 1.5, 3 over 2, this 2 is gone, so it would be 3 1.5 minus 1.4, it would be very small. It would be 0.1, but it would be positive. And why is that so? Because this component of A, vector is long, but sine of 30 is small. Vector 2 is twice as short than this, but sine is big at 1.4. Divided into 2. So this is a little bit bigger, so the sum would be something, Cx would be here, roughly 3.6, and Cy would be 0.1, and so the vector would be this plus this, and this would be this vector, and this would be C. And we know Cx, we know Cy, and we can obtain everything we want. We want to use Pythagoras theorem and obtain the length of C. We can obtain this angle like this divided over this, for example, and it will be tangent. and then we use reverse function, inverse function, and we obtain the angle. So this is one example. And another example may be incline, and on this incline there is a body, and this angle is theta, and then there is this force mg, and this is N, and then this is a friction, F friction, and they want us to know everything is balanced, no movement. They want to know us all the forces, how to solve it. It's very easy to solve. You can write N plus F friction plus mg, and this should be equal 0. I will not go into this why and what, but we have vector, the sum of vector equals 0. When there is, for example, you can do a different system of coordinates. Let's say first we will do this system of coordinates. This is x and this is y. So you say along x n is directed this way, this projection of n. So, and if this is theta, then this is theta. So we immediately have that it will be minus n, and this would be sine theta, just because this angle is theta. The next is friction. Friction goes here, it's going into the positive, so F friction, and it would be cosine of theta. And mg is perpendicular to this, so there is nothing. So along the y-axis, so n going up, so n positive, and it would be cosine theta. And I'm not stopping, not explaining those sine, cosine very much. I want to give you an idea. And then F friction would be again positive up, so it would be plus F friction, right? And this would be sine theta. Trust me on those sine and cosine, it's just the idea of how you use this projection. mg is directed straight down again, so it would be minus mg. And this would be this solution against this system of coordinates, right? Of course, you can use different system of coordinates. For example, like this, y is here and x is this way. And this way would be the same equation, but we have to, and in both cases, it should be 0, right? Because projection of 0 equals 0, right? So, solving in this system of coordinates, x this way, projection of n doesn't exist because n is perpendicular to this axis, so it would be 0. F friction is going straight back, minus F friction, right? And then mg, this is theta, that means this is theta, then mg will be positive, plus mg sine theta, if I'm not mistaken, and I don't think I am. And this should be equal to 0, because this 0 I'm not forgetting at this time. Y, projection n on y, it would be n full. F friction is not, has no component along this axis, so it would be plus 0. And then mg this way, so it will come with minus amg cosine theta equals 0. It would be a little bit different system, but trust me, it would be absolutely the same solution. The system doesn't affect the solution, it only allows us to write those two equations about some objects that are vector direction, one dimensional on this way, one dimensional on this way, or one dimensional here, one dimensional here, and all we know that the body complex movement is combination of one direction here, one direction there, because directions are perpendicular. Or for example, let me imagine that we have a rope, and this rope is like a pendulum, but only it rotates like a cosine, it rotates like this. Pendulum normally is this, but it rotates like this, so it stays on the same kind, it's cosine. It's not like that, but it's cosine. It's not cosine, it's kind of cone. It's like creates a cone during its motion. Okay, it's again, let's look on this. We have tangent and we have gravity. And we know that tangent plus gravity equals ma. How to solve it? Y, x, alpha or theta, and then we're looking on this system and we're saying that along x, t sine theta plus 0, because mg is directed this way, no affection, equal ma and ma mv squared over r. Don't ask me why, trust me. Y, I project t on this, it would be, and it goes vertical, so it would be plus t cosine theta plus mg. Mg full force, so, and it goes this way, minus mg equals 0, because it's rotating in this plane. So it's not moving down. Another case, right? So this would be always much easier to solve with projections. Let me solve another problem. Let's say we have this direction and we have 45 degrees. And we have this vector which is 5. And we have the same vector which is 5. And this is 45 degrees. Let's solve it. Naturally, this is y, this is x, and we want to find vector a plus vector b equals vector c. And this is a, and this is b, and we want to solve it. Well, 5 projection on x. It would be 5 cosine 45. Plus b, it would be 5 cosine 45. And it would be cx. Along y, 5 goes up, it would be this vector, it has component directed y, so it comes to with a plus, and it will be 5 sine 45. And we go with this, it would be minus 5 35, minus 5 sine 45. It would be cy. And it's a special case. Sine 45, they cancel out, and those double, so we have 10 cosine 45 equals cx. And we have 0 equal cy. What that means? Well, of course, it's obvious. This component of this vector directed up. The same component is directed down. Of course, they cancel out. This component this way and the same from this. Of course, they double. So this is straightforward. This is a rare case when parallelogram may be even simpler. Very rare case. Because if this is 45 degrees and this is 45 and this is together, this is 90. This is 5 and this is 5. If we draw a parallelogram, they are already in the same point. So if we draw a parallelogram, this parallelogram will become a square. If this is a square, then obviously the sum would be directed along this diagonal, along this line. And in this particular case, we immediately can say that this is diagonal as twice of a side multiplied by sine 45, right? Or divided, it's the same. It's diagonal. It's straightforward. So square root out of 2. And that's basically it. 2 is gone. This is 5. And this would be 5 multiplied by 1.4. You figure what it will be. It will be approximately 7. Check what your calculator tells. But this way we have to think, we have to notice rectangle, triangle, whatever, square, parallelogram becomes square. But here we do it even without thinking. We just have this projection, and we get the result. So, what I'm trying to say is that more often than not, we will be solving problems, and I would give you just a couple examples. And it will be noticeably in dynamics, in second law of motion, in statics, when everything in balance, with all kind of friction, with all kind of pendulums, with all kind of springs, anything like that, there would be always vector, because force is a vector. And not always they will be directed one way. Sometimes there would be an angle, and more often than not there would be an angle. And how we will be solving this? More often than not, we will be solving it through projection. So remember that if you have a vector, you always can say that this vector is the sum of those two vectors. And this vector is projection on horizontal axis, and this vector is projection on vertical. And then say that, oh, okay, the vector is just two things completely independent. One thing along this line, another along motion. Total motion is in the plane, but it's a combination of two independent motions, this motion and that motion. And it would be all over. So, the main thing that you should remember is that fx equal f cosine theta, and fy equal f sine theta. And theta and cosine is something else altogether, but I gave you a primer on these two in previous 3 clips, so you can look, and I advise you to look and to become fluent. Sine, cosine, that it's never more than 1, or always bigger than -1, when it is 0, when it is 1, sine of 45 degrees, what is pi over 2. Only practice will make you comfortable with those. Don't try to memorize, just try to do, and every time you have a problem, go to the video, rewatch it, stop it, pause, do it, try to do it yourself. See what I am saying about this. Maybe we're in agreement. Maybe we're not. Then find out who is right. Do it yourself. And this way you will not memorize it, but you will remember it by using it over and over again. So, this concludes this Vector 101 primer. And this playlist, I hope it would be my last one in this playlist. And I return putting problems in playlists dedicated to kinematics and very soon mechanics, dynamics, second law of motion and stuff like that. Subscribe, bell, like, question, comment, your problem, and I see you next time. Thank you.